Hey, hi, hello guys. Welcome back to Code with Nani channel. So today we're gonna discuss about lead code problem of the day: minimum recolors to get a k consecutive black blocks. So you are given zero-based string blocks of length n, where each of the character in that particular string it will be of a white or a black, representing the ith block of the color. So you are given integer k, which is a desired number of consecutive black balls. So in one operation, you can either recolor a white ball such that it becomes a black color, return the minimum number of operation needed such that there is at least one occurrence of k consecutive blocks. So basically, they were saying there will be a possibility of at least one occurrence of k consecutive blocks. So what you need to find out is you need to return the number of operation required to make a k consecutive black balls. So which means I'll give an example. So in the input array you are given. So let's just understand the example. So I'll get clarity around the question. So as you can see, we are given a block of string which is w b b w w b b w b. So we need to get a k we are here k is 7. We need to get a 7 consecutive black balls. As we can see, the maximum consecutive black balls that we have is 2, here as well as 2, yeah, just 1. So the maximum the consecutive blocks that we have right now is just 2. So in one operation you can make a white ball as a black. Suppose in one operation you can make this white ball as a black. Okay, so we need to return the minimum number of operations such that we can achieve a 7 consecutive balls. Suppose, let's just think, you can convert this as a black ball. An operation is 1. Convert this as a black ball. 2. This is a black ball. We have 3 operations. 1, 2, 3, 4, 5, 6, 7. So if you if you consider this situation, if you applied a 3 operation on this white balls, then you can get a consecutive 7 balls. Okay, so you cannot reduce further, because in any case, in other case, you'll reduce these to black ball, reduce this to black ball, and this to black ball. So we'll have 2, 3, 4, 5, 6, 7, 7 black balls in a consecutive manner. They can be a more than 7, but at least we need a 7 consecutive balls. So that is the minimum number of operation that required for this particular string to convert into a 7k consecutive black balls. We cannot reduce further. We cannot get by using 2 operations. So that is the answer. Suppose if we take another case, which is w, just w b w b b b w. Now the case 2. We need to find a 2 consecutive black balls. Suppose if you carefully observe this particular substring, we have a 3 consecutive black balls, right? So as you can see, what is the required amount of the black balls? That is 2. We already have a 3 black balls, so no operation is needed. That's why we just simply return 0 operations. So that was the desired answer for this particular test case. So how do we approach this solution? Approach this problem statement. So what's the intuition behind this problem? Suppose as you are a given string, right? W. Suppose we are a given string W B B W W B B W B W. Okay, this is the given string. Okay, this is the string. So if you carefully observe, what is the k? Here k is a 7. So we need a window size of k, right? So if you carefully observe, what is this problem statement reminds you of? So it is a static, and what is that? Static sliding window problem. So how do we approach? So what we can do is we can maintain a static window of 7. 1, 2, 3, 4, 5, 6 until here. Okay. 2, 3, 4, 5, 6, 7. Okay. So in this particular window, if you want to make everything back, what is the minimum number of operation required? Because if you want to make this whole window into a black, so what is the minimum operations required? Because we have a three whites, right? We have a three whites. So what is the minimum operations required? So equal to 3. And as you already find this window, there might be a case in another window which we get a minimum number of operation, right? Like there can be a chance, right? So let's just ignore this and reduce the count of the white ball as well. Suppose if we are iterating through this window, we are just counting the whites. What is the number of whites? 3. Suppose if we are changing the window, now the window becomes this, right? Now the window becomes this. So in that case, we'll check the left pointer. If the left pointer is white, we'll just reduce the white count minus minus so that we achieve the exact count of the whites. So in this window, we have a 2 whites and 3 whites. So still answer will be the same. In the next iteration, so as you can see, if we are changing the window, the left pointer is reducing, which means like left pointer is increasing, and we are like making incrementing the left pointer. And as you are iterating, what is the pointer that is being incremented? So we are maintaining a left and right pointer. So left pointer, always remember in this sliding window technique, always in this particular window, always left pointer will stay as the starting of the index, and right pointers will stay in the rightmost part of the index. This will be the sliding window of 3, 4, 5, 6, 7. So as we check of as we check this window, we are just concerned about the next window. So in that case, the right pointer will increase. If right pointer increase, what we need to decrease, because now the window size has been increased to k plus 1, then we need to reduce this L as well. So now the L will be shifted to here. As we are shifting L, what we need to check? We need to check whether this element is a white or not. If it is a white, we need to reduce the count of white, or else we'll just do nothing. Okay. So that is the real intuition behind our problem. So I'll just give you another example so you'll get clear picture about it. Suppose we have a string W, B, W, B, B, W, right? Triple B, W. So here case 2. Okay. Case 2. In the first step, we just put left pointer as 0, right pointer as 0. So whenever we find a white block, we'll just increment the count, because at the end what we are calculating is we are just calculating how many operations required. So if we had a black, we never make it as a operation, because we already have a black ball. When we have a white only, then we consider for a operation to convert into a black ball. So in the black ball condition, we never required any operation to do so we only require the count of the total number of white balls in a particular window, right? So as L is equal R0, then we find that the particular string indexed element is a white. So we'll just simply increment the counter. And we need to check if R minus L plus 1 is equal to K or not. Why R minus L plus 1? Because as it is a zero based index, if it is a all or R minus L will gives you a zero based index, uh, not the count of the element. So just increment by 1. So that will gives you the count of the element. If R minus is equal to 1, in this case we are in the zeroth index, it is not the case. Okay. Then we'll just simply increment the right counter. Okay. Now L is here. Now R is here. Now check if S of I is equal to Y. Why? In that case only, just increment the count. Okay. Now, no, it's not a white ball. So I'll just reduce. As you can see, now we reach the k limit because we already have a 2 elements. Okay. In that case, what we need to do? Answer is equal to minimum of answer comma. What is the count of the total white balls? We have one white ball and one black ball. So in order to make two consecutive black balls, we require one white ball to convert into a black. What is the count? Count is 1. So answer in that particular instance, the answer is equal to 1. And as as we checked for a particular window, then what we need to do? We need to just shift the window to the next element. In that case, L will be incremented because we are right side incremented, so we need to reduce the left side window as well, right? Like as window size has been increased once, then left part also should be increased by 1, right? In that case, we'll check if s of left is equal to white, which means that left is an which in which the left part pointer points is a white ball. We need to reduce the count because in that particular window we have a white ball, right? If it is not included in that particular window, we'll just reduce the count of the white ball. Okay, cool. And now the L is pointed to here and R is pointed to here. Now check, as it is a white ball, we just increment the count. And again the count is 1, and the same answer equal to answer of CT. If left side is a black ball, so we never it's a black ball, so we don't need to decrease the element, so still the count will be a 1. And then now and so on. Suppose if we are getting to here left pointer, and if right pointer stays here, we don't have any counter as particular value because the count is 0, because in this particular window we don't find any white ball. So in that case, answer is in that case the counter is 0, and previous minimum value of answer is 1, which is the minimum. Answer is equal to 0 because out of 1 and 0, minimum value is 0. So just storing it in the answer. And like even for this particular window as well, we don't have any white ball, so still answer will be the same. But for the last window we have a one white ball, so in that case answer is 1. So out of all the windows, all the static windows, what is the minimum possible answer on the count value? It's just 0. So in the end, just return answer, right? Then just return answer. So that makes sense, right? So I'll just walk you through the code so you'll get clear picture around my solution. And what is the time complexity of the solution? Because we are only iterating from the from left side to the right side. In each side, we're just reducing the left pointer. So that that does only take of one time. So in order to traversing from the starting index to the ending index, it takes of n time. So the total time complexity be of n. And space complexity, because we are not using any specific data structure, so it just say of 1. So this is the time complexity and space complexity of my solution. Suppose if you have solved more optimized way, do let me know, put it in the comment section, so I'll more happy about that solution. Let's just walk you through the code in the Leetcode. Let's just zoom in so I'll see clearly what I'm doing. I'm just pointing a left point, initializing left pointer as 0. What is this W? It is the white block count. And what is the answer? I'm just, there might be a case where why I'm doing it answer as a why I'm doing, suppose we have a string of length 7. 1 2 3 4 5 6 7. Yeah, suppose this has white, okay, and the k is also 7, the same as the s. Okay, so in order to make a k consecutive blocks, how many operations required? We need to convert it to black, and black. So what is the maximum possible answer that you can get it from here is just the string length. You can think of a situation where k, which means like if suppose the k is 8, means we only have a 7 white balls, but we required 8 consecutive balls. But there will be no such situation, because as in the question, if you carefully observe, they mention that such that there at least one occurrence of k consecutive black balls. So they are clearly mentioning that there could be one solution for that. So in that case, k never exceeds the s dot length. So for that sake, what is the highest possible value of that answer will be s dot size. What I'm doing, I'm just iterating from right from 0 to, like from 0th index to the s dot size. In each iteration, if that particular element is a white ball, we are just incrementing the count of the white. Okay, if if we reach a particular window size, if we reach the window size k, then what we need to do, we need to update the value of the answer which is minimum of ans comma count of the white balls, and we need to increment the left pointer as well, because in each iteration the right pointer is increasing, right? So we need to neutralize that increment, right? So if s of l means, it means a left pointer is a white block, we need to reduce the white block. If not, we'll just not consider that situation, and we'll increment the l, and the n it answer return answer, which holds the minimum number of operations required so that we find a k consecutive black balls. Let's just run the code. Let's just submit the solution. Voila, it's submitted. And that's it for the today video, guys. So if you like my explanation, do like my channel, do like my videos, and subscribe to my channel and hit that bell icon so you never miss any notification from my channel. And if you had any queries regarding my approach or regarding my code, do let me know in the comment section so I'll reply you out. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow with a great content. Bye bye.